Alright, let's solve for x in 5x to the power 4 is equal to 7x squared minus 2. Well, what you want to do is, in order to solve, what you need to do is move all terms to one side. So I'm going to move this and this term to the other side. So you get something like this. And let's say that this expression, this is a polynomial expression. Let's call this guy f of x. So in this case, you need to fully factor this first, and then you can solve for it. So if I want to fully factor this, I'm going to use a combination of remainder, factor theorem, and some form of division, right? Either synthetic or long division. Now, this is x to the power 4, so I actually need to find two factors, right? Or you could do synthetic division twice. I'm going to find two factors and employ long division. So if I'm looking at f of x is equal to 5x4 minus 7x squared plus 2. Right, let's use the integral zero theorem, IZT, to find potential factors. So the potential factors here are basically factors plus minus the factors of the constant over plus minus the factors of the leading coefficient. Okay, so this is basically going to give us plus minus factors of constant, which is 2, so 1 and 2, leading coefficient plus minus 1 and 5, right? So some of our potential factors are plus minus 1, 1/5, 2/5, and 2. Okay, let's try positive 1 first. I think that's usually like a off the bat kind of choice to pick. So let's do f of 1. So if you do f of 1, you get 5 times 1 to the power 4 minus 7 times 1 squared plus 2. You can actually notice that it's 0. So f of 1 is equal to 0. So according to factor theorem, x minus 1 is a factor. Okay, then what you want to do is you want to test at f of negative 1. So if you do f of negative 1, you get 5 times negative 1 to the power 4 minus 7 times negative 1 squared plus 2. And you can actually notice here that this also gives you 5 minus 7 plus 2. Right? I'm just going to erase that, which also gives you 0. So f of negative 1 is also 0. So this tells us that x plus 1 is a factor. So therefore x plus 1 and x minus 1 are factors. And if you multiply these two collectively, you expand it. Or you can use FOIL, or you can think about a plus b times a minus b, which gives you a squared minus b squared. Well, this gives you x squared minus 1. Okay, so this gives you x squared minus 1. Now, because this is a factor of our expression, our quartic expression here, but this is not a linear divisor, then you can use long division to solve for the remaining factors, right? So if you're looking at this, I'm just going to do it out here. Okay, so your dividend here is 5x to the power 4 minus 7x squared plus 2, right? And your divisor here is x squared minus 1. And the name of the game here is to match the first term, basically the leading coefficient and the leading term, right? So to match that, I'm going to multiply this by x squared, because we can understand that x squared times x squared minus 1, if you expand this out, you get x to the power 4 minus x squared, right? So I'm going to write that, sorry, I should multiply that by 5x squared, because you get 5x squared minus 5x to the power 4 minus 5x squared. Sorry about that. Right, so you have to match the term as well as the degree. So you get 5x to the power 4 minus 5x squared. Then you subtract the 2, right? So 5x to the power 4 minus 5x to the power 4 is 0. Negative 7x squared minus negative 5x squared. So you have to make sure you do the integer operations properly. Right, so you get negative 2x squared here. Then what I'm going to do is I'm going to bring down the positive 2, and then you want to match the leading coefficient, basically this leading term here, right? So you want to match the leading term, so I'm going to multiply this by negative 2, so you get negative 2x squared plus 2, and you can see that everything kind of cancels out, right? So this negative 2x squared and negative 2x squared cancel out, and the 2 and 2 cancel out, so it's 0. Okay, so this is your quotient. So collectively, this is what you'll get. You'll basically, you should get something like this. We'll just, let's use a different color. So you should get 5x squared minus 2 times x squared minus 1, and you can factor this back to its original state, x squared, 5x squared minus 2, x plus 1 times x minus 1, right? So this is your new expression, right? So you can equate this to 0, so you can see that therefore x is equal to plus minus 1, so negative 1, positive 1. You can also solve for the 5x squared minus 2 is equal to 0, move the 2 to the other side. 5x squared is equal to 2, divide by 5 to solve for x. So x squared is 2 over 5, and if you square root it, right, so x is equal to plus minus square root of 2 over 5. Okay, so this is also equal to plus minus square root of 2 over 5. Okay, so basically those are our solutions, right? So you can also include this guy as well. Okay, so that's how you can, if you plug these values in, you should satisfy the equation.